What about diffraction for a circular opening? Diffraction of a circular opening, single slit, two slit, we have found the formula, we derived it, we took the questions. What about this slit which is circular? So there will be circular diffraction. So diffraction of light passing through a circular opening produces circular interference fringes, often blur images. For optical instrument, whenever the diameter gets higher, that D, capital D, there the problem increases. So this is how the fringes are seen. You see they are blurry also, but you can perceive the fringes. So how about resolution of images? Resolution is basically the two particles or two objects that can be perceived or that can be seen clearly. So if you see these two objects, if you go back, means if the distance is higher, you will see those both to be one. You will not be able to find distinction between them. They will appear same. So just consider a pinhole. So this is a pinhole. As two objects, they are getting closer. The interference fringes, they overlap. It will be very difficult to distinguish these separate images. So clear image when we have a distance, otherwise not. So what will be the resolution limit? Images can just be resolved when central maximum of one pattern coincide with the first dark fringe of other pattern. That is, if the D, this distance, the pattern they are producing, if it is not of the range when center maximum of one coincide with the first dark fringe, you will not be able to see. Let me explain it to you. The only thing is the object have to be far apart, otherwise you will not be able to see. These are two separate images. How you can see? Because in the second figure you are not able to see because you have crossed the resolution limit. But what is the resolution limit? The central maxima, let us take the central maxima, that is the middle one, the highest peak, that is the central maxima. So what about the second one? The first dark fringe of the second one should coincide with the central maximum of the first one, then only you will be able to resolve. That means, what is the dark fringe of the second one? This one, okay? And this is coinciding, see, this is coinciding with the central maximum of the first one. So that is how the resolution limit is achieved. Then only if the central maxima or one is coinciding with the first dark image of the second one, then you will be having separate images, otherwise not. What is the resolving power of an instrument? The resolving power of an instrument is the ability of that instrument, how it can produce well-defined separate images. Separate images. So there is the diameter of that optical instrument, of that lens, and there will be a limiting angle as well. So this limiting angle, the distance, all is defined. For smaller angle, we always know that sin theta can always be taken as theta. From mathematics we know. So the limiting angle of resolution for a circular opening is given by a formula, which is theta, or in many books it is written as theta 0. So this theta is given by 1.22 into lambda by d. Lambda is the wavelength. This d is the diameter of the optical lens or the optical part of the instrument. Okay. So this theta or theta 0 is given by 1.22 into lambda by d. This is the limiting angle of the resolution. This is the resolving power of instrument. If you see, there is a figure also which shows the eye, how it resolves different objects. So resolution and distance, how they are related. These are two objects. This is the diameter, this is the optical instrument. This is the theta, which we are calling it as a limiting angle. So the limiting angle of resolution, which is already which we saw just now, 1.22 lambda by d, is equal to S by P, or you can call it as S sub 0. S sub 0 by P. What is S0? The distance between the two objects. And what is the P? Distance of these objects from the lens or the optical instrument. Okay. Let us take a formula here. Using this formula, let us go to a question. The tail lights, the lambda is given by 632 nanometer of an auto, are 1.2 meter. So these are the tail lights. So we are talking about these two tail lights. These are 1.2 meter apart, and the pupil of the eye is around 2 millimeter in diameter. So here the example is of eye. So we have a lens, right, in our eye. how far away can the tail lights be resolved as separate images? 2 millimeter diameter is of eye, pupil of eye. So we will use the formula which we just saw. This is the figure. Tail lights are shown in red. P is the distance from here to here. This is your eye. D is the diameter of that eye. So theta is given by 1.22 lambda by d. This is equal to S by 0 or S sub 0 by P. S is, by figure you know what are the values. So P is given by S sub 0 into D by 1.22 lambda. All the values are known to us. 1.2 meter here. This is S. D is 2 millimeter converted into meter by multiplying it with 10 to the power minus 3. 1.22 is there. Then we have 632 converted into meter. So multiplied by 10 to the power minus 9. And finally, you get P as 3.11 kilometer. After 3.11 kilometer, you will not be able to differentiate it.